Hi. So I thought I would do this little video to kind of help you. Well, my idea is that sometimes we're given a lot of information in like a word problem, and I'm trying to help you focus on just the information that's important that you need in the word problem, because they tend to provide a lot of information that is not so important. So let me go over a problem in a few examples and show you. Okay, so here's a problem. Speaking of information that you don't need, let's erase all this up here. Get that the picture for you. Jessica is collecting bugs for her class project. She found 3 bugs under the rock, 4 bugs in the log, 6 bugs on the sidewalk. How many bugs did she find in all? So in math, you want to focus on the subject or the section, the exact section that you are in. And I know this is a little bit cheating, because in real life, you're not going to be able to focus on, oh yes, this is an addition problem. And because I know it's an addition problem because it's in the addition section of your textbook. But that is what you can use when you are just learning the material. So if that's the case where your teacher is going to test you on just chapter 13 material, then you can kind of use that, or especially when you're doing the homework for a particular section, use the fact that this is going to be an addition type problem, or this is going to be a ANOVA type problem, and really use that to help you focus on the words that you need to focus on. And sometimes that's not, I think that works a lot of the time, like 98% of the time, or so. Like 2% of the time, maybe they'll throw a random problem at you that is not from that section or something like that, and they'll even say on the question review. But usually that works really well and has worked well for me in the past. But let's go over. So what I would say is anticipate the type of problem that this problem is even before you read it, right? Based on the section of the book you are in. Okay, that is just a helpful, and these are just more like kind of like almost cheating, tips. It's not that you're cheating, but I'm just saying these have worked well for me, and they're not like always work well. But okay, so let's look at this problem. If I know that I've been working in addition, and I anticipate that this is an addition type problem, then the only words that really are important to me in this problem are how many bugs, and I would just how many bugs in all, right? This is the most important few words right here. How many bugs in all, right? So this is telling me I need to add up all the bugs. And then from there, I just go looking for the numbers that I might need in this problem. So 3 bugs. This goes on to explain where that you found the bugs, but that doesn't matter, right? as far as you doing this problem, 4 bugs, blah, blah, blah. That's, again, explaining where you found it, but it's not important. And 6 bugs. These are the only important words to solve this problem correctly. So you just do 3, this 3, right? Plus that 4, plus this 6, and that's how you solve this problem, right? So just let's focus here for a second. Like, Jessica is collecting bugs for her class project. This sentence, even if I didn't understand a lot of the words in that sentence, like, it's just telling us that it's an addition. It's just reinforcing, I guess, that it's an addition problem. And it's just kind of there to make a story, to tell a story more, and not to give us any information to solve the problem, right? And then this information about, oh, she found them under the rock, like, it doesn't, we don't care where she found the birds. I mean, the rocks, that's not gonna, in the log and on the sidewalk. Those are all unimportant information, right? It's all unimportant. So you'll find in these type of math problems that really focus on the words that are important for the math, for you to solve the problem. And when you do that, you think about, I need 3 numbers, and I need but that pretty much, other than that, I mean, you have to make sure that the same, what are we adding up? Bugs, 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 bugs. That's important, and the numbers are important, and probably the words, how many bugs in all, but all those other words, all these other words in pink that I'm showing you are not important words, right? And so if I was a second language student and I don't know very much English, if I don't know a word, I think it causes you to have a lot of anxiety when you see a word like sidewalk and you're like, I don't know what that is. It causes a lot of anxiety. But I would just take a deep breath and say, I only need, the only words, there's very few actual words that I needed to know. And most of the time, if you're listening to the videos and you're in lecture, you're going to be hearing the words that are going to be the important words. And you're going to be picking up on those words. These other words that you don't recognize, you probably don't recognize them because they're probably not going to be important. So don't let that, that stress you out. Okay. Let's go over a statistics type problem that is in this type of situation. Because a lot of times we just want to put a story to go along with the numbers, just to make it more real life like, but really you don't need that story, and they're not important to you finding the answers that you need to find. So let's see a statistics type problem. Okay. So, I think this is an important topic that sometimes in learning, it is so important that we be able to filter out all the unimportant information and focus on the important stuff. And sometimes we have to simplify things for ourselves in our minds so that everything is not, so that we don't get overwhelmed, like, mentally. So let's look at this statistic type problem. I'll read it to you, and then I'll go over, what's the important information here and what's not so important. So an educational psychologist is examining response times to an on-screen stimulus. The researcher believes there might be a weak effect from age, but expects a more pronounced effect from different color contrasts. She decides to examine a black on white combination compared to 2 alternatives, red on white and yellow on blue. Here is the data for response times in milliseconds. So they give us this chart table, And then they say statistical software was used to run a two-way ANOVA test, and the results are shown below. So we have this table, and then and they say at the 0.5 level of significance, answer the following questions. And they ask, what is the conclusion regarding interaction effect? What is the conclusion regarding main effects? And what is the conclusion regarding the effect for color? Okay. So I know when you get to the actual, real life of doing statistics, the details about particularly what you are testing and the different factors and what they all are, they matter, right? But to us as students, we're not that concerned about whatever they're testing. We could say whatever it is, we're testing something, right? And so they give us this beautiful background story up here, but they're just telling you a story to go along with this data in the chart below, right? So, I mean, unless this is telling us there's no numbers in all of that stuff, there was no numbers. And in all of that stuff, they weren't telling you directions on what to do. So this is just, all of this paragraph is just kind of just giving you a pretty story to go along with the data and making it seem more real life like. But if I didn't understand all of that information, it doesn't really affect me, right? Because normally this is important to notice which area. Now, before I say all of that doesn't matter, we have to focus on what section we're in. Okay, because depending on the section, maybe that does matter, but we're focused on two-way ANOVA. And the thing with two-way ANOVA, I only want you to really interpret the results. So I'm only really focused on whether you can read these P values and tell me, what the conclusion is based on those P values. So that's the only thing we're focused on here. So, and we're focused on age, and you got to know this is the age factor. This is the P value for the age factor right here. And then this is the color factor, and this is the P value for the color factor here. And this is the interaction element, and this is the P value for the interaction. That's the most important information in this. That's all you need to solve this problem, right? Because all of this information was just a story to go along with it to make it seem more real, right? And this information, we didn't even need this. Normally, you might put this into the calculator to run your two-way ANOVA, but you don't really need to here. And then it says statistical software is used to run a two-way ANOVA test, and the results are shown below. So you didn't really need to know. If you didn't know what statistical software is, like, who cares? You would say that what would be important to know is what a two-way ANOVA test is, right? You know what that is. And then, oh, I'm sorry. I did it in pink. I apologize. These are the important information right here. So these are all in yellow. Yellow, 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 yellow. Okay, so that's all the information that we really need to know in this beginning part of it. Even this table is just pink because all these numbers are pink as well. So they're unimportant information that we didn't actually really need to know that information there. Okay, let's go down to here. They say at a 0.05 level of significance. So that's important, right? That's important. The level of significance is important. They ask, what is, and what is the conclusion regarding the interaction effect? So what is the conclusion? That's important. The interaction effect. So we're going to find that answer, we're going to look at interaction, the p-value for interaction. If the p-value is low, right, less than the level of significance, then you reject the null hypothesis that there's no interaction taking place. This is huge that we see the p-value here, 0.02 is smaller than 0.05. So what is the conclusion regarding the interaction effects? We would say that we are going to reject the null hypothesis that there is no interaction. So if we're rejecting the fact that there is no interaction, it seems like a double negative there. That means there is interaction, right? We're saying we don't believe the null hypothesis, which is no interaction. We don't believe that. We don't believe no interaction. So it means we do believe that there's interaction going on between these two, okay? And then, okay, so let's look at the next one. The next important piece of information here is what is the conclusion, right? What is the conclusion regarding age? So that means that we're going to look under this row age, and we're going to look at the p-value for age, and it's 0.42, which is not less than alpha, right? So we failed to reject the null hypothesis that there's no effect. We failed to reject. So the null hypothesis says there's no effect from age. And we fail to reject that, which means that we agree with the fact that there's no effect on age. So then next to last, it says, what is the conclusion? These are the important words. What is the conclusion, right? Or what is the color for the effect for color? What is the conclusion for color, right? So then that means I have to look over here and look under the row color, and then I look for the p-value under color 0.115. And again, if the p-value is low, then I reject the null hypothesis. There's no effect for color. It is not low, so we failed to reject the null hypothesis that there's no effect. So we believe there is no effect due to color. Okay, so I hope that this really kind of helps you focus on the and weed out the unimportant words in word problems and focus on what's important. Because in a 2A ANOVA test, sometimes if they ask you, we may need this table information if they ask you to actually run the test yourself, which I won't do with 2A ANOVA because we need different statistical software to do that, which we don't have. Your TI-84 and Excel and all those don't do that level of statistics. So we will not be doing, I'm not going to ask you to do the 2A ANOVA test, but you would need this information if we did, okay? And this is the output. So I'm providing the output that you need. And then so the only really important thing here is to state the conclusion. And to state the conclusion, we need to know the p-values, right? To decide and make decisions about whether they're rejecting or fail to reject, and then just say what that means, you know, as far as the null hypothesis and alternative hypothesis. Right. Oh, one more thing before I leave. I just want to remind you, it gets confusing to me. So let me just remind you of the null and alternative hypotheses. Here they are. So for the interaction effect, the null hypothesis is that there's no interaction. Okay. And the null hypothesis for the main effects, or there's no effect of factor A, no effect of factor B. So just remember the null hypothesis is that there's no, right? No interaction, no effect, okay? All right, that's that. And that means the alternative is there is an effect or there is interaction, okay? That can kind of help you. All right, have a great day, everyone. Bye.